So we've been reviewing graphing lines for a while. Let's look at graphing inequalities and solving systems of graphing lines and inequalities, linear inequalities. So again, we have, this is going to be our beginning point, our y-intercept, and that's where we're going to start. We're going to put on, it's positive 2 on the y-axis, and my slope is negative 1 over 2. Remember, it can be negative 1 over 2 or positive 1 over negative 2. I can go rise negative 1, run positive 2, or I can rise positive 1, run backwards 2. Either way, that's all going to be on the same line. Now with inequalities, you've got to be really careful because we've got to be looking at this sign. This says I want everything greater than the line. I don't want greater than or equal to the line. If I have a greater than sign or a less than sign, I'm going to put a dotted line in. If I have a greater than or equal to sign or a less than or equal to sign, that's not less than though, it's going to be a solid line. I have a greater than sign, so I'm going to put a dotted line in. It says that I want y to be greater than the line. Well, here's my line. Here's my y-axis. Up is greater than, down is less than. So I want to somehow indicate that I want everything greater than this line, every point greater than this line. Now, a lot of people just do this and scribble. That's not going to work in a couple minutes, okay? So I'd rather you not scribble. Now I have to erase all that scribble. That's good enough. I would really rather you do just straight lines all in one direction. You'll see why in a couple screens. Okay, now I can do this in two ways. I know we can solve for y. Okay, quickly solve for y. I'm going to subtract, I'm going to add that 3x and divide by negative 2. When I divide by negative 2, my inequality switches just like it did in equations. Whoops. And 10 divided by negative 2 is negative 5. And I can plot that using my y-intercept and my slope. The other way I could do it is with intercepts, and just knowing that my x-intercept is when y equals 0. So if I plug negative 3x minus 2, I'm going to plug in a 0 for the y, subtract 0, so that's going to cancel, divide by negative 3, x is negative 10/3. Okay, so the x is going to be negative 10/3. Y-intercept is when the x is 0, and if I plug in x, and instead of x I want to plug in a 0, that will cancel. Divide by negative 2, and y is going to be negative 5. Okay, so I'm going to go back and I'm going to plot this, and then I'm going to show you how these end up being my intercepts. So again, this is going to be negative 5. So going back to the original y equals mx plus b, I'm going to start with negative 5. 2, 3, 4. Put a point on negative 5. I'm going to do positive 3 backwards 2. Positive 3 backwards 2. Since this is a greater than or equal to, I'm going to have a solid line that's going to look like this. Okay, now let's deal with, I want everything greater than or equal to. So greater than or equal to. So again, this is my line. I want y to be greater than the line, not less than the line. So I'm going to shade, again on this side, with just lines. I'm not going to scribble. Now let's look at what we did down here. Okay, My x-intercept is negative 10/3, which is about negative 3 1/3. And if you look, I cross about at negative 3 1/3. And my y-intercept is negative 5. And if I come down here, I cross at negative 5. So, looking at my intercepts, I could also just connect them with a solid line. So either way you want to graph, using intercept or y equals mx plus b, you're still going to get the same graph. Now we're going to talk about systems. A system is two or more graphs in one problem. Notice I changed the word from graphs to functions. Right here, I have two lines. I know they're lines because the exponent here is a 1 and they're in y equals mx plus b form, mx plus b form. So this would be a linear system. I could have 3 lines, I could have 4 lines, I could have a parabola. But right now I have 2 lines. I'm going to graph these 2 lines, and I always do them in 2 different colors. So I'm going to graph this first one in red. I have a y-intercept of negative 2. I have a rise of 3 over 1. Don't forget the over 1. I could also go negative 3 and backwards 1. And I'm going to connect. This is an equals. So I am no longer at inequalities. I now have equals. So equals means I just draw a line. I don't shade either way. Now I'm going to do the other one. I'm going to do it in blue. So I'm going to start at 9. And I'm going to go negative 2 over 3, negative 2 over 3, negative 2 over 3. So just graphing this system gets me 2 graphs. If I ask you to solve the system, I am looking for the point of intersection. That point is very obviously right here, dead in the center. There's my point of intersection. It is the point 3, 7. So my point of intersection is 3, 7. If I ask you to solve a system, I'm looking for the point where it intersects. What that means is if I plug this point in, 3, 7, so 3 here, 9 minus 2 gives me the y, which is 7. Yes. If I plug 3 here, I get negative 2 plus 9 gives me the y, which is 7. Yes, this point is on both lines. That would be the solution to my system. This is a system of inequalities. I have 2 or more equations, there are 4, and I have inequality signs. And I'm actually going to change a couple of these. I'm going to make this equals, and I didn't want that in purple, I want that in black. And I'm going to make this one equal to. Okay, so again, I'm going to graph them all in different colors. I'm going to graph this first one in purple. Y is greater than 0. Okay, remember, a y equation is always a horizontal line through this y. So y is greater than 0. This is going to be a dotted line. So I'm going to put a dotted line through y equals 0. And I'm going to shade everything up. Now I'm going to look at this second line. I'm going to do this in green. That's red. I'm going to solve that for y. If I solve that for y, I'm going to get y is less than negative 1/2 x minus 3. I'm going to put negative 3 on. I'm going to go negative 1, positive 2, or positive 1, negative 2 to get closer to the purple. This is a solid line, so I'm going to draw my solid line in here. And I want everything less than this line. Okay, so I want less than, so that means underneath the line. Now, all of this down here doesn't matter because what I'm looking for is where these 3, so the 3 different colors intersect. The only place that the red and the purple will intersect is this little triangle right here. Now let's look what happens if we do the next one in green. x is less than or equal to 2. Remember, an x equation is a vertical line. So less than or equal to will be a solid line, vertical line, through x equals 2, and I want everything less than. But just like I was saying before, the only place that matters is where the three colors are going to intersect, which is going to be right here in this little corner. The last one, let's do in blue. If I were to solve that, I would get y is less than 2 over 5x plus 2. Remember, when I solve for y, when I divide through by the negative 5, this is going to flip to a less than. The greater than will change to a less than, because when you multiply or divide by a negative, you flip the inequality. So let's graph this. I'm going to go to 2. I'm going to go positive 2, positive 5. I'm going to go negative 2, negative 5. 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5. And this is going to be a dotted line. I want everything less than this line, which means I want everything underneath the line. If I start putting in underneath the line, will this ever intersect my other three colors, which are here in this corner? The blue will never intersect this. So is there anywhere where all four of these will overlap? There is not a place. So therefore the answer here would be no solution. You can also write that like this, the empty set.